video I'm wanting to talk about compound ions. So we've looked at ionic bonding and how ionic bonding occurs, and we just looked at it between just actual kind of atoms, and you've probably looked at creating ionic formulae in a previous video from the atomic structure section. So I just want to have a look at these things called compound ions. So compound ions are covalently bonded species that carry a charge. So they won't be just atoms that have lost electrons, they're actually whole kind of molecules that carry a particular charge. Now, if you want to see how any of these have formed, I would probably go to the video on dative or coordinate bonding. In there, there's some examples of how these are kind of formed. So let's start having a look at these compound ions then. So this table is on page 5 of your bonding notes part 1. So I'm going to suggest that you pause the video now and have a go at filling in that table, and when you come back you can have a look and check that you've found the correct ions. So here is our completed table. So we've got the ammonium ion is the only kind of positive compound ion here. That's the example that is in the dative covalent bonding video. We've also got the hydroxide ion. We've got 2 nitrate ions there. We've got a cyanide ion, hydrogen carbonate ion, a hydrogen sulfate ion, carbonate ion, 2 sulfate ions, a hydrogen phosphate ion, and then finally the phosphate ion. So it is a good idea to know these compound ions, to know the charge of them, to know not the structure essentially, but to know the formula of them, just so you are able to write out formulae of more complex ionic compounds. So knowing these is kind of like an important part of the A-level chemistry course. It'll help you a lot along the way. So going back to the table, you will notice that we have 2 nitrate ions and 2 sulfate ions. So we've got nitrates that are followed by the Roman numerals 3 and 5, and then sulfate we've got 4 and 6. So those Roman numerals relate to the oxidation state of the nitrogen in the nitrates and the sulfur atom in the sulfates. Now, at the moment, I'm not going to go on to go into detail about oxidation state. If you want to kind of know more on it, this should be in the redox notes. So at this stage, I would just know the difference between a nitrate 3 ion and nitrate 5 ion, and later on in the course we will talk about those Roman numerals and oxidation states. So moving on, I'm going to go to the table that is further down page 5, and we're going to look at writing out the formula for compounds that contain these compound ions. So you are required to know the formula of some of these compounds and to be able to work them out. So like I said, it is important that you know what those compound ions are. So I'm going to do one example for you, and then I'm going to leave the table for you to pause the video and you can have a go at doing some of these formula yourself. So I'm going to start with a nice easy one, sodium hydroxide. So this compound contains sodium, as it says in the name. So a sodium Na, and it contains the hydroxide ion. So if you go back to your table, you will see that the hydroxide ion, OH minus. So we need to know what the charge on the sodium ion is. So sodium is in group 1, so 1 electron in the outer shell. So sodium's going to lose that 1 electron, lose something negative, become positive. So we've got a positive sodium ion with a 1 plus charge because we've lost 1 electron, and we've got a hydroxide ion with an OH minus charge. So we've got 1 plus, 1 minus. We'll just have one of each come together and form NaOH. So just another example before I let you fill out this table yourself. We have calcium chloride this time. So in there we've got calcium. So calcium is in group 2. So 2 electrons in its outer shell. So calcium is going to lose those 2 electrons and have a 2 plus charge. And then we've got the carbonate ion. If we look at the info on top, we've got CO3, 2 minus. So we've got a calcium 2 plus ion, and we've got a carbonate that's a 2 minus ion. So those charges are balanced, 2 plus, 2 minus. So we only need 1 calcium and 1 carbonate ion. So our formula would be CaCO3. Okay, so I'm going to let you have a go at filling that table in, and pause the video, and when we come back we'll have the answers here. Okay, so here is the table that is filled out, so you can have a go at checking some of your answers. So just one thing really to point out just in terms of kind of brackets. So we'll have a look at the barium hydroxide example. So in barium hydroxide you have barium ion, which is a 2 plus ion, and you have an OH minus ion for the hydroxide. So because barium is a 2 plus, hydroxide is a 1 minus, you are going to need 2 hydroxide ions to balance out the charge with the barium. So normally we'd just put a little 2 subscript, so a little number next to the particular atom that there's 2 of, but because we've got a compound ion, it's 2 of the whole compound ion, so 2 of all of it. So to show that in the formula, we only need 1 of the bariums, so we've got Ba just on its own, and because we've got 2 of the hydroxide ion, we put the OH and we put the O and the H in brackets with a little 2 outside. So again, same with can we look at calcium nitrate. Calcium has got a 2 plus charge. The nitrate 5 ion has got a 1 minus charge. So we need 2 of the nitrate ions. So we need to balance in order to balance out that charge. So 2 of the NO3s. So when we write it out as a formula, we've got 1 of the calciums, and the whole of the nitrate ion, the NO3, is in brackets with a 2 on the outside. If you're still a little bit unsure about writing out ionic formula, I would pop back to the video on creating ionic formula from the atomic structure notes.